So hi folks, welcome to our talk on performance metrics in a day. So basically the agenda of this talk is to give you an idea of how to get started measuring your performance through your Selenium tests. So basically giving you ideas, different methods, you can use them however your need for complexity is. Maybe you only need the basic options, maybe you need more complex performance metrics gathered. We're also going to try and keep the presentation as practical as possible, so we'll be showing a fair amount of code snippets, we'll be keeping it short, we've got a lot of information to cover in the 30 minutes that we have. So also before we dive in, we're going to be representing the HAR format a fair bit. Those of you who were at David's workshop yesterday will probably have some idea of what it is. There's also other performance metrics methods that he covered that we're also going to give a bit more details on and maybe another perspective. So the HAR format itself, it's just a simple JSON format, encodes UTF-8, and it's just there to represent the performance metrics. It's becoming the standard for all these tools that you use for performance metrics gathering. So lots of tools will help you'll easily import, export, or view the HAR format in a nice graph that's visually nice to look at. Also, there's plenty of libraries out there that'll just serialize and deserialize the JSON into objects themselves for ease of accessing the information inside it. Just an example of what it looks like. It's very basic. It'll just show where you grab this data from. So in this case, Firebug and Firefox versions. You can encode then the overall page data, and then for the entries is corresponding to the items that were downloaded. So say you had lots of CSS and JavaScript files on your page, they'll show up in this, and it just gives, you can just capture all the details that you want, such as the headers, the response headers, the content body, etc. Also, there's just free tools out there that you can just paste in the HAR format into a text box, and it'll nicely break it down and show you there. So for example, here we loaded up google.com, and you can see the basic workflow that Firefox went through to download all the items. So the first item obviously downloaded so they can figure out what to download after that. So that's why there's a large enough gap between the first item and the rest of them. Fiddler supports all these, and show slow. You can basically beacon out your HAR format up to their site, and they'll act as like basically an archive for you. So as any talk about performance metrics begins with, we ask, well, what metrics do you want to gather? So obviously the very basic is the overall page load time. Maybe that's sufficient for you. Maybe all you care about is when I click on a link, how long does it take for the next page, subsequent to the page, to actually trigger the onload event. If that's not sufficient, maybe you want to dive down and say, well, in the browser, what are the particular DOM ready states? When is it rendering for the first time? When is it rendering the top fold, etc. Then you dive down further, and you may want, okay, well, I've got lots of items on my page, and the overall page load time is not really telling me much, because say I've got a CSS file or even a JavaScript file that's taken a disproportionate amount of time to download. So you may want to gather each item and say, okay, well, this took X amount of seconds to load, and the others were fairly fast. So beyond that, once you've gathered all those metrics, you may want to also gather in the headers, status codes, and the content. This will basically used for debugging purposes or diagnosis. So you notice that one JavaScript file that was fairly slow, so you maybe want to go look, oh, the header compression wasn't enabled, so that maybe explains why that was so slow. So now I'm going to just enumerate some of the methods we're going to cover. So obviously, the easiest starting point is just embed your own start-end timers in your Selenium tests and say, okay, start timer, get google.com, end timer, very basic. Maybe that's sufficient for you if you've got a very simple site or it's local hosted or whatever. But most people will probably want to move on to at least some of the following options. So the next one was navigation timings that David showed in the workshop yesterday. That's now a nice standard that's been built into the browsers, so IE9 and Chrome currently support it. It's very easy to use. It's a nice JavaScript API that you call, execute JavaScript off the WebDriver Selenium handles. Then you may want to jump into the browser plugins, and the advantage of these is they'll give more information on the state inside the browser. So say the CPU usage or things like rendering times, when it was rendered, what particular stages it was rendering in, and an example of that is web page test for IE. After that, there's the proxy solutions. So these will just sit there, funnel all the HTTP traffic through them, and then you can ask them afterwards, well, what was the performance metrics, and they'll usually spit that out in HAR. And then after that, the lowest level is obviously put on a packet sniffer on your machine and just get the raw data according to the network device that you had and get the timings from there. So I'm going to jump right in, and obviously method 1 is very simple. I'm not going to patronize you much longer, but start, end, subtract the 2, you're done. Method 2 is the web timings. So it's very simple. Like, put this inside your Java file, your main, and you're done. You load up, in this case, webmetrics.com. And after that, execute the JavaScript to extract out the 2 timings you care about or more. There's lots of different variables inside the web timing standard. So in this case, we just took the 2 endpoints, navigation start to load event end. The nice thing about this solution is it's very flexible. So you may hear a term bandied around as perceived load time. So say, for example, Amazon.com, you'll note that they optimize their page load to get up the navigation items, the search bars, etc., as fast as they possibly can, and then they dynamically load after that as much as they can get away with. So the onload event in this case might not be what you really classify as my page is done. So this is a nice way to go about it, where you say, okay, I'm going to embed some JavaScript on my page, and I'm going to dictate that my page is done when this particular element appears in the DOM or on the page. An image or something is loaded. So in that case, you might say, okay, set a JavaScript variable containing the timestamp of when my element appeared on the page, and then use that in conjunction with the web timings API, JavaScript variable. So in this case, as you can see, the simple example is my JavaScript variable. Just subtract the navigation start, and you've got your perceived load time. So it's a nice thing you can do now with the built-in support of the JavaScript. Here's just a diagram that I ripped directly from the navigation timing spec sheet. I recommend reading the spec. It's very simple, very short, fairly straight to the point, and they'll just cover what workflow that these particular variables are set in. I don't expect you to read them all. It's fairly small font. But the idea is that here's your workflow of how the page is loaded, some begin points, some end points. Maybe you care about the ones in the middle, maybe you don't, DNS resolution time, etc. So the only the not so good part about this solution is that it doesn't give you the per item downloads. It doesn't tell you how fast each individual item took to download. So if you've got a lot of third-party content, you don't know what the DNS resolutions for those were, and you can't really break it down as far as you want. But maybe this is sufficient for you, so you can make your own choice. So the third method was the browser plugins. So there's plenty of options here where you can, for IE, say use web page test, Firefox. An easy solution is the Firebug and NetExport extension to automate exporting your info. Dynatrace is there too. Chrome, I didn't really look into it too much, but I'm sure there must be some way to export the data from the network panel, which is equivalent to Firebug. So the advantage of the browser plugins is you can measure extra state beyond the previous solutions, where you can say, okay, well, how long was the JavaScript executing for? Like, have listeners in there, CPU usage, render times, etc. So as I said, the example that I'll just enumerate here is Firebug and NetExport. This is as far as I could cut the code down to. Just some details on here. It's easy enough to dynamically load in the 3 extensions that you need to get the solution working, the Firebug, NetExport. NetExport is just an extension for Firebug, and its very basic task is just export either manually or automatically the current data that's been captured in the net panel. And Firestarter is just an activation extension for Firebug as well, and just helps it come up for the first time when the browser loads. Some of the preferences here that you need to set, obviously auto export active would just turn on NetExport's automated function, so you don't have to manually click export. So your Selenium test can just go to the site, and on the onload event, this function is the NetExport is activated and says, okay, I'm going to get all the data from the net panel and dump it out in HAR. Some of the Firebug settings, excuse me, should be obvious. On by default. Default net panel name, not strictly necessary. It's just a nice way to switch to the net panel to see what's going on. And obviously, next setting is just to enable it. And it's very simple to use. So this is just a screenshot of what it looks like when this test is actually running. The red box is just around to show that that's all NetExport is there. It's just a nice way to export out the data that Firebug has already gone to the trouble of collecting for you. So now there's the other solutions, the proxy. I'm going to hand it over to Mark, who's done a lot more work than I have on the proxies and knows it very well. So there you go.
All right, thanks. OK, so I'm just going to go over how you'd use a proxy to gather the same metrics the chain was going over. So the main thing is grabbing the HAR file, which is a list of all the HTTP items that are downloaded and all the headers and timings and everything else that's associated with that. So there are a couple of different options. With Selenium 1, there's a built-in proxy. I'm going to go over using that. For a WebDriver, you have to use a third-party proxy, and there's a few solutions available. So I'm going to go over two good ones. There's also some additional benefits of using a third-party proxy that gives you finer-grained control over how the requests and responses are made. So I'll go into that into a bit of detail. So first of all, the Selenium proxy. So if you're running a Selenium 1 test, you can use this capture network traffic API, and that'll basically give you a list of all the traffic that occurred since you started running your test. So each time you call this capture network traffic, it clears out the buffer of the previous network traffic that's been there, so you can call it multiple times and get, for each part of your test, a list of the traffic that occurred. So this returns you the data, all the data you need, but it's not in HTTP archive format. It's something very similar. I've got a list of all the stuff it includes here. I won't go through it all, but the downside is you can't load it into the HAR viewer applications that are out there. But you do have all the data, and it's probably pretty easy to write a tool to convert it into that. So this works with Chrome and Firefox. I couldn't get it to work with IE. I'm not sure if there's a way around that or not. Like I said before, it doesn't work with WebDriver. And there's no real control over the proxy. So even though it's routing everything through the proxy, you don't really have any programmatic control to change things as it's going through the proxy. So what do I mean by changing things when it goes through a proxy? So there's a bunch of additional benefits you can get out of using a proxy. So you can do things like blacklisting, whitelisting URLs. So if you have a website and you want to just monitor the performance of my website and not all the third-party content, you can use blacklisting to do that. If you don't want to get ad impressions or analytics when you're running your tests, which would be something you may want to do, you can blacklist them. You can blacklist those particular URLs so that they won't be made. So when the browser sends that request to the proxy just returns back status 200 OK or something, and the request is never made to the ad server. A similar vein, URL rewrites. So this allows you to, when the proxy gets a request for a particular URL, you can rewrite that URL somewhere else. So say you're testing a staging environment and some of the URLs are still pointing to production, you can work around that by pointing them back to staging again by using this URL rewrite feature of the proxy. You can also do assertions based on are you making the right requests? So is my web page contacting the analytics server? Is it contacting the ad server? So you can tell things like that based on just by looking at the requests that the proxy made during your test. Another thing you can do is header changes. So you can modify the HTTP response request headers. So there's lots of examples. I won't really go into them all, but one thing is auto authentication. Another one is you could modify the user agent. So say you're testing on IE and you want to test some older version of IE. What does the website respond when you give it a different user agent string? So you could use that for testing like mobile applications inside Chrome or something if you want to be really hacky. So another thing is waiting for all HTTP content to be downloaded. So say you don't want to wait for the onload event. Say you have a lot of content that's downloaded after the HTTP or after the DOM has loaded and after all the images have loaded. You might have a lot of AJAX requests. So one thing you could do is ask the proxy, is anything downloading still? And if it is, continue waiting. Another thing is limiting bandwidth. So you might want to simulate the tests under low bandwidth situations. So you could set the upstream or downstream bandwidth in the proxy. So what proxies support this kind of thing? So we have two of them. So one of them is the BrowserMob proxy. This is an open source cross-platform proxy written in Java. So it's got a friendly API and exports the HTTP archive format as well, and it does pretty much all the things I just enumerated in the last two slides. The source code is available at that URL there. So here's a code example of exporting to HAR. So basically, you just you create the proxy server, and then you tell WebDriver to use that proxy server when it's creating Firefox, when it launches Firefox. So you do that through this desired capabilities API here. Then the next thing, to actually export it to a HAR, you can tell the BrowserMob proxy that you want to start exporting to HAR. So you call proxy.newHAR. And then every time you want to create a new page, you call new page, and that will show up in the HAR file as a separate page. So the HAR file viewer allows you to see different pages inside the HAR file, so you get all the HTTP items underneath each page. So where I have driver.get, that's where you put your Selenium test. So you might have a Selenium test that goes to the main page. The next page might be log in, and the next page you might want to log in the HAR file. Would just be doing some operation on your website. So that would give you 3 separate sections where you'd see just going to the main page, going to the login, and then doing whatever action you wanted to do. So to actually write out the HAR file, it's this easy. So you just call proxy.getHAR and then write to and specify the file. So obviously you can do things like upload it to show slow or put it through HAR to page speed to get more metrics out of it. So how do you do those things I was talking about earlier, or those extra testing benefits you get out of using a proxy? So there's a whole slew of different APIs on the proxy object that we have, and I've just listed a few of them here. So the first one is blacklisting, whitelisting URLs. So it just takes a regex. So anytime the proxy gets a URL that matches that regex, it just sends back whatever response code and an empty body. Redirecting URLs, you just pretty much the same thing. So it takes in a regex. Anytime you get a match to that, it replaces it with whatever the replacement string is. Limiting bandwidth is that you just set the downstream and upstream bandwidth. So when would you use the BrowserMob proxy? Well, since it's in Java, obviously, if you're writing your test in Java, you'd probably want to use the BrowserMob proxy because you've got direct control to it, and it's very easy to use that way. It's cross-platform, and you should use it when you can set the browser. So when you can set the proxy. So in my previous slide, sometimes you're not able to set the proxy on the browser like this, depending on the browser. So if you can do that, you should use the BrowserMob proxy. Otherwise, you might need to get some manual way of doing it. So the BrowserMob proxy is still being worked on, so there will be bindings for other languages as well through a REST API, but right now that's not available. So another solution on Windows is to use FiddlerCore, which is a .NET library. And basically, this is the library that Fiddler itself is built on. So Fiddler is an application that allows you to monitor HTTP traffic, and it shows a nice GUI for looking at all the HTTP traffic that's downloading on your machine. So it's got all the same features as the BrowserMob proxy. It also configures itself as the default Windows proxy by default and supports proxy chaining. So if you already have a proxy on the machine, the FiddlerCore will use that. It can decrypt and intercept and change SSL traffic because it inserts its own certificates. So to start, so I'm just going to go through the code for starting the Fiddler proxy and how you'd use it. So I'm just going to go through this really quickly. So the first line here just starts the proxy, registers it as the system proxy. The second code snippet, just each request that comes in, it adds it to a list. Then you run your Selenium test as normal, and as each item is downloaded, each HTTP item is downloaded, it will be added to the list of items. So then to export, there's a basic formats exporter. So you just load that in to your application, and then once you've done that, you can use this code here to export it. There are lots of different options available for the HAR. In this particular example, I'm just saving it off as HAR archive 1.2 format. So you can do all the same features that I was talking about earlier with modifying the request. So you register an event handler. So before the request comes in, you have a chance to respond to it. So in this case, I'm just sending back a response code 200 if it's going to any external content. So I'm only interested in my website. I'm not interested in the performance of all the rest of the content there. So this allows me to compare the two, so I can see what's the performance of my website with the third-party content and what's it without. And so I can do some debugging there later on if I need to. You can also modify responses from the server. So before sending the response back to the browser, you've got a chance to intercept that and change the headers, all the data that's sent back and everything. So when to use FiddlerCore, it's Windows only. So if you're on Linux, you're out of luck. So it's cross-browser. It'll work with any browser on Windows, and it's .NET. So pretty much the only way to call it is true .NET. So if you're using something else, you'll have to load in the .NET environment and call it through it. The other method of recording the HAR is not using a proxy. So you can use this to kind of verify what's actually happening on the network. So sometimes using a proxy can introduce latencies, or it can introduce problems. The browser may behave differently or something like that. So you might want to use this, just capture the network traffic and save it off to a HAR file and compare the differences to really have confidence that the proxy is not really interfering with things. In general, it doesn't, but this is just good to know. If you do run into something where you're not really sure if it's the proxy or not, you can run this. So on Windows and Mac, you can run TCP dump, and on Windows you can run WinPcap, and this saves off a PCAP file, and then you can convert that to a HAR format using this open source project called PCAP to HAR. So I kind of went over this. If it captures all the HTTP traffic, so it's all the HTTP traffic on your machine. So you need some way of figuring out. You don't want to be running a whole load of tests at once, because this is not going to. It's going to give you all the tests running at the same time, and you're going to have a very difficult time figuring out which request is which. So that's it. So I'm just going to give a brief summary of all the stuff we went over. I know it was pretty quick, but I think we're on time still. So we discussed 5 different methods for gathering performance metrics. So one is to put timers around your Selenium commands. It's very basic, very easy. use the new web timings API, which is available in Chrome and IE9. Firebug and NetExport, which they went over yesterday. So basically, every time you go to a new page, if you added that code snippet we gave, it'll drop a HAR file each time you go to a new page. Use the proxy that I just discussed to capture network traffic. You can use the built-in Selenium one, or you can use the third-party like Fiddler or BrowserMob proxy. And the other thing is sniffing the network traffic to get an actual idea of what really went on the machine and have full confidence in it. So that's pretty much it. Did any have any questions or queries? Concerns? All right, thank you.